Welcome to the Worldwide Center of Math. Today we've been taking a look at the basics of probability. One of the things that we're going to be often asked to calculate is the probability that at least one or at least X amount of one event occurs. So the probability that an event occurs at least once, or that we get at least one success is normally what we're looking at, success and failures here. The probability that we get at least one success is equal to 1 minus the probability that we get no successes. We're going to take a look at probability of at least 2 is 1 minus the sum of 0 and 1 success. And we can define that to the general case. The probability of at least X is going to be 1 minus the summation from n equals 0 to x minus 1, the probability of n successes. So the golden rule to remember here is going to be that the probability of A plus the probability of not A, or the complement event, is going to be 1. So basically what we're looking at is probability of A is 1 minus probability of not A. Now we're most often going to be looking at successes and failures. So basically what we're going to do is just take a look at some examples and see how this applies. And then later when we're looking at, in the next video, when we're looking at Bernoulli trials and the use of binomial probability, we're going to see how this can be taken a little bit further. So the first example we have states there are 3 reactors in a chemical plant, each independent of the other, and each of which has a 90% chance of running when an experiment begins. The experiment needs at least one reactor to work. So what is the probability that at least one reactor works? So we have the probability of a reactor working is 90%, or 0.9. And we want the probability that at least one of them works. So that's going to be 1 minus the probability that none of them work. And the problem gave us that the reactors were independent of one another. So the probability that none of them work is the probability that A and B and C don't work, which is 0.1 for each. So we just have that probability is 0.1 cubed. Go ahead and plug this into your calculator, and you're going to get 0.999. Which is a 99.9% chance that at least one reactor works. So the scientists conclude that they have a pretty good chance of their chemical reactor working. So now we're going to take a look again at some dice rolls. We're going to take a look at 5 dice rolls, and the question asks, in 5 dice rolls, what is the probability that we get at least one 6? Well, that's going to be 1 minus the probability that we don't get a 6. And again, we're not told right away, but we know that the dice rolls are all independent because on each dice roll you can get 1 through 6, and the outcome of 1 doesn't affect the outcome of the next roll. So we just have 1 minus, and there's a 5/6 chance that you don't get a 6. And we said that there's 5 dice rolls, so probability that dice roll 1 and 2 and 3 and 4 don't get a 6 is just going to be 5/6 to the 5th. Go ahead and plug that into your calculator, and you're going to get 0.598. .598 you can leave your probability as that, or you can say that it's a 59.8% chance that we're going to get at least 1 6. The next one we have, at a mathletes meeting, 5 men and 3 females attend, and 3 are selected to compete in the next math competition. What is the probability that there's at least 1 female in the selection group? That's just 1 minus probability that there are no females, which is 1 minus probability that it's all males. And we have that the probability of the first male is 5 out of 8. The probability of the second male, well, these are not independent trials, because if you take 1 man, then you have 7 people left and only 4 men. So it's 1 minus 5 out of 8 times 4 out of 7 times 3 out of 6. And that probability is going to be 1 minus 5 out of 28, or 23 out of 28. So that's the probability that at least 1 is going to be female. And the last one we're going to look at, a teacher gives a pop quiz with 4 questions that are true or false, and we have a student who has no idea what they're doing, so they guess at each, and we're going to find the probability that they get at least 1 wrong. Well, that's 1 minus the probability that they get them all correct, which probably isn't going to happen. Student has a 1/2 chance on each question, and each question is independent because they just guess on every question. So it's 1 minus 1/2 to the 4th. And that's going to equal 0.9375. So the student has a 0.9375, or 93.75% chance at getting at least 1 problem wrong. And just keep this in mind. This is how you calculate probabilities of at least 1. Thank you for watching. For more math videos, please subscribe to our YouTube channel here. Or for additional resources, including affordable digital textbooks, please visit centerofmath.org.